Alright guys, welcome to 3.1 Solutions to Linear Equations. This is for Math 0314. Let's start with this first question. Is negative 2, negative 4, and 0 negative solutions to x plus y equals negative 6 and 3x minus y equals negative 2? Well, the first question is what do we mean? Okay, so what's important to realize is that when we solve these problems, we can always examine from a pictorial perspective. So if you have two lines that are crossing, okay, where they cross is what we mean by solutions. Now what I want you to note is that graphs can cross. We can also have scenarios where if the lines are parallel, the graphs will never touch, right? If you're drawing two lines and they're parallel, they'll never touch. We can also have a scenario where you have one line and then you have another line that's directly on top of it. And in this case, if you have one on top of the other, then they not only touch, but they touch at every possible point. Okay? So there's tons of scenarios that we can have, actually not tons, three. There's three scenarios that exist, and we need to be aware of each of these. Alright, let me get rid of these graphs here. So the question emerges, well, how do we know what the solutions are? So one way of deciphering the solutions is if I give you two points, you can substitute those points into both equations and see if they're true. So notice if I substitute in negative 2, negative 4 into the first equation, that's true. If I substitute negative 2 and negative 4 into the second one, I get negative 6 plus 4, which is also negative 2, and that's true. Okay. If I plug in the second point, which is 0, negative 6, then I'll get that it's true for the first one, but on the second one, we'll get 6 equals to negative 2, which is not true. Okay. And that should be apparent because these two lines are not the same line. So if they cross once, there's no way that this was going to work anyways, right? Because it would be the first scenario where they have, and I'm not saying this is what the graphs look like. But they would have to, of course, if they're not the same equation, they either touch once or they never touch at all. Okay? So just like in section 1, if in this section, if you get a point, remember the first coordinate is x, the first component is x, the second component is y. You can always just substitute the points in and see if it's true. But what about if I ask you to graph? How do you go about graphing this to find the solution? So we know how to graph. We spent the last section working on that. So we're going to subtract x from both sides, i.e. we need to get y by itself. We're going to subtract 3x from both sides. I get negative 3x minus 2. And this one's a little bit more complicated. I'm going to have to divide through by negative 1. And I get y equals 3x plus 2. So I have two equations. I have y equals negative x and y equals 3x plus 2. So what do I do from here? Well, we like this format, which is y equals mx plus b, because to graph, all I have to do for the first one is start at negative 6, 1, 2, 3, 4, 5, 6, and the slope is negative 1 over 1, which means I go down 1 over 1, and my graph looks something like that. Then I graph 3x plus 2, which means I start at 2, and this one goes up 3 over 2, and it would look something like this. Now keep in mind that if you do go, I said up 3 over 2, didn't I? My bad. The slope is 3 over 1, so I should be going, one second please, up 3 over 1. So it should be a little bit steeper. Should look like that. And they cross. And where they cross is my solution. Now notice that if I can go, like I was saying earlier, if I can go up 3 over 1, then it stands to reason that you can also go down 3 and to the left 1. So if I can also go 1, 2, 3 over 1 and continue that process. Now without graph paper, this becomes a little bit difficult to graph. So let's look at it on graph paper. So again, my equations were y equals negative x minus 6, and the other one was going to be y equals, what was it? 3x plus 2. So here's some graph paper. Let's graph it. So this is 1, 2, 3, 4, 5, 6. Okay, so the slope is negative 1, so that means we go down 1 over 1. We can also go up 1 over 1. And here I'm putting in a lot of points when I draw my line so that I can clearly see where there's going to intersect. Okay, the other one is 3x plus 2, so we're going to start at 2, and we know it's going to cross in quadrant 3, so we're going to go down 1, 2, 3 over 1, 1, 2, 3 over 1, and this is our point of intersection right here. And so we know that this is our solution. So what is our solution? Well, we can see we go, let's do this in different color. We go over 2, so that's negative 2. We go down 1, 2, 3, 4. So the solution is negative 2, negative 4, which you should be thinking, well, yeah, that makes sense, because earlier we said these are the same equations. Negative 2, negative 4 is the solution. So there we have it. All right. Let's move on. So the next question is solve by graphing f of x equals 3 and g of x equals 2x plus 1. So what I want to stress here is that instead of calling this y equals 3 and y equals 2x plus 1, we call f of x equals 3 and g of x equals 2x plus 1. But this just means one of your graphs is y equals 3 and your other graph is y equals 2x plus 1. So a question should emerge which is, well, why do we call it f of x and g of x instead of calling it just y? And the reason why is if these graphs are different, we want to call them something different, right? But with that being said, let's go through and let's graph these. So the first one was f of x equals 3, and the second one is g of x equals 2x plus 1. So how do we graph f of x equals 3 or y equals 3? Well, remember, y equals 3 is nothing more than a horizontal line. Okay, that last bit did not come out nice. Here's our horizontal line. 2x plus 1 means I start at 1, and my slope is up 2. Remember, 2 is the same thing as 2 over 1. So I go up 2 over 1, and we have our intersection right here. So the answer should be 1, comma 3. Okay, we could test it, right? If I plug in 1 here, notice I get 3. This one says y values are 3, so the answer should have a 3 in it. And there we have it. All right, and that's about it. The book goes through more examples, but graphing is not really one of the main ways that we go about solving this. Or I just wanted to expose you to it. Next time we're going to talk about more concrete. Concrete's not the right word. More pragmatic usages of solving these. All right, so hopefully you're cool with graphing, and I'll see you in the next video.